Hi folks, welcome back. I hope you're all doing well. So Fred Brooks, in his famous book, The Mythical Man Month, proposed the idea that there is real overhead to increasing the size of a team that's working on a software project. He famously said that adding more people to a late project makes it later. However, here is a paper that does some empirical investigation into data from open source projects and looks at how those projects scale with respect to the number of people working on those projects. Hence the title of this paper. They find that the whole is more than the sum of its parts, and they find superlinear productivity in these open source projects. What they mean by superlinear productivity is that if you double the number of people on a project, what they find is that the productivity of the project increases by more than double. Details and definitions matter a lot here, so let's look at what their data set was, what metrics they're looking at, and how they arrived at their conclusions. To start with, they'll look at about 164 open source software projects, ranging in size from pretty small, 5 contributors, to pretty large, more than 1,600 contributors. Then the next big question, of course, is, well, how do you measure the productive output of an open source software project, or of any software project for that matter? The obvious idea is to look at the lines of code or the number of commits and relate that to the number of people working on that project. This simple idea doesn't quite work because the output of a project is an interplay of various time-varying factors. So it depends at what point in time how many developers were working on it and what the intensity of their contributions was over that time period. So we need to be able to capture this time dimension as well. The way the authors propose incorporating time into the analysis is that they partition the project into fixed time windows. And then over each of those time windows, they look at the number of active developers as well as the activity happening in that project. The next question then is, once you divide the project into time windows, what measure of productivity do you look at? You could either use lines of codes or commits. Now, it's pretty well established by now that just looking at raw lines of code is not a good predictor of quality or even productivity of software projects. And so the authors here look at the number of commits. The reasoning is that the checked in commit really is the fundamental unit of work. That's the thing that gets code reviewed, tested, and it is a unit of work that gets added to your software repository. Let's look at the major finding that came out of the data. This particular graph is only for the Apache project, but it is representative of the pattern that they found in their data set of open source projects. What we're looking at here is, on the x-axis, the log of the number of contributors in 5-day time windows. And on the y-axis, we have the log of the productive output, which is the number of commits over that same time window. Note again that these are logarithmic scales, so a straight line here implies an exponential relationship between these two variables. And crucially, what they find is that the slope is greater than 1. It's about 1.5. So the relationship looks something like this, where the output is the number of developers raised to some exponent beta, and they found for the Apache project beta to be about 1.5. Over their entire data set, beta was about 4/3. And this is what explains the title of the paper, because 2 raised to the power of 4/3 is 2.5. Notably, these results hold up even as we vary the time window from 1 day to 10 days. Now, this is quite a surprising and counterintuitive, and yet a really hopeful finding. There's a lot of anecdotal belief in the software engineering community that the cost of coordinating large groups is more than the benefit in effort or productivity that you get from having such a large number of people. And the data that the authors see over here proves that that is not the case, that indeed, as you add more people to a project, the output of that project increases superlinearly, which is to say that if you double the size of a project, the output increases by more than double. The authors also do some more study of how exactly this effort is distributed, and at least theoretically, they find that these contributions are not evenly distributed, and indeed that there are a few exceptional contributors that make up the bulk of the output. Now, this jives very well with some other research which looks at the role of heroes in open source projects. Indeed, I have another video on this channel, I'll link it down in the description, which talks about this phenomena of heroes in software projects, how they have oversized impact on the project, and how the quality of their work is much better than the quality of the average contributor to the project. I'd encourage you to check out the rest of the paper because it goes into more detail about some of the underlying mechanisms that might lead to this kind of superlinear growth in output. But the top line finding of growth actually being superlinear with respect to the number of contributors is still a very surprising and promising and counterintuitive finding. So I hope you enjoyed that, and I will see you next time. Thank you very much.